This is Hati, a 3D platformer about a wolf from Norse mythology. As the price for having been born as the son of Fenrir, Hati is doomed by Odin to forever chase the moon across the sky. Having whiled away my free time for too long, it's time for me to give back to the gaming space. I've started with nothing but a blank Unity scene, and asset by asset, line of code by line of code, I seek to build the best video game a rookie indie dev can. The overarching goal for this episode is to set up all the basic movement abilities for Hati, barring two, which are deserving of their own devlog. To begin with, for now, we're going to create a state machine for Hati to run on. A state manager will control all of Hati's actions. Beneath the state manager are a number of scripts that all act as certain states, like idling, walking, running, and jumping. The great thing about this setup is that within each state, you don't have to handle all of the movement logic. You just have to handle the logic for the state that Hati is currently in. However, in order for this to work, each state will need to implement an interface. An interface is like when you're madly in love with someone. So you propose to them. You say, "I will always love you when you're sick, pick you up when you're down, and take care of you until you die." Interfaces are kind of like that, just for scripts. The only difference is that if you break your promise when you're coding, instead of divorce, you get a compiler error. Each state needs to promise to have a function for enter, tick, and exit, so when the state manager says, "run the enter function," it can run the enter function. Even if it's empty, it needs to exist, so that the computer doesn't get upset at the indolence of humanity. I rarely have to use exit, so it's kind of the black sheep of the family, but don't make it feel too bad about that. It's very sensitive about its uselessness. Something about the system to keep in mind is that while the state manager has the function for changing state, only the states themselves ever decide when it's appropriate to switch to a new state. Therefore, we need to initially enter a state from the state manager to start the process off. Now that we're getting into actual coding, I'd like everyone to know that I'm still fairly new to coding, and in the beginning of this project, I wrote many things that I now cringe horribly at the stupidity of. If you know anything about coding, and you're wondering what I was high on when I wrote this, nothing but ignorance. And my daily dose of LSD. If you're able to follow along with my code, take a shot every time I place state changes in the middle of the tick function and without return operators to escape the rest of the current function. There's a general structure that states ended up taking. First, the state animation starts playing on enter. Then every frame in tick, the player's input is received, we check to see if the player is touching the ground, and we check several conditions to see if we need to change state. Walking and trotting is combined into one state, because they're basically the same thing, just with different animations and moving at different speeds. The player can press a button to switch between them. At the top, we define an enum, which is basically just a list of words, one of which can be the value of the variable at any given time. We use this variable to keep constant tabs on our walk-trot value across state changes. The only other difference from idle is we calculate our movement, which will be further discussed later. Alright, so jumping is when things get a little sussy, but here we go. On entering the state, a timer starts running. Once the timer reaches a quarter of the way through the animation, it adds to the player's Y velocity using a formula I later found out is suboptimal. The end of the jump animation triggers a state switch. When I first tested this code, I found I couldn't jump more than one time. This was because I hadn't reset the timer on entering the state. I feel like this mistake really speaks to my programming inexperience at that point in time. This issue caused me to revisit my change state function, as I originally had no idea what was causing the bug.
This is bad! This is very bad!
I added a previous state variable so I know where I came from. Think about this from the user's perspective, and in this case, I am the user. Think about this from my perspective. If I want to enter a custom animation transition length, not only do I have to provide a number for the animation transition, but I also have to say true. I do in fact want to use this number. And if I don't specifically state true, it doesn't do anything. Imagine being the person who is just trying to figure out why their optional parameter isn't working and bug testing for an hour only to realize they have to add a true onto the end. And there's no system to notify them that they had to use the true in the first place. What a sick, twisted, maligned mind. Only a deranged lunatic of the highest caliber would devise such a system. And it's me. I'm literally doing this to myself.
It's time to stop! It's time to stop, okay?
Eventually, I came around to an answer. I found the light of God in function overloads. Rather than the horror I was doing before, you can either write the function with or without an animation transition amount, and regardless of what you do, everything works fine. It's weird that I put the exit state before null checking, but you can't win them all. Even so, vast improvement. How to make spaghetti code with Holo. Add at least 8 useless variables to your class. Bring water to a boil and add spaghetti.
Faster.
Why? What? Mix in a generous helping of pointless if statements. Once pasta is thoroughly cooked, strain the water and add marinara sauce. This is a critical moment in the cooking process. Before the pasta cools, be very careful to make your state switch checks as simultaneously redundant and broken as possible. Finally, top with cheese and seasoning of choice.
I'm putting that in.
Fortunately, we're getting away from the hell of spaghetti code with the next bit. The jump logic is separated into 3 states. The jump itself, a generic falling state, and a generic landing state. We can massively cut down on all of the intrascript conditionals by not having to constantly check timers. The falling state starts with the falling animation, which is currently just a bit of the jump animation on loop. The state can increase in horizontal speed to a maximum amount, so the player has some maneuverability in the air. That leaves the landing state. It's basically a slower version of the walk state with a different animation. The only real difference is, after a certain amount of the animation plays, it automatically switches to a new state. The next thing I wanted to fix was allowing the player to jump in place. When I first coded the jump function, I figured I would want the player to be jumping forward no matter what. I'm not sure why I figured that would make sense, but I sensibly changed my mind on it. I was way too Boolean happy when I first started learning to code. By Odin's saggy scrotum, these checks seem unnecessary and prohibitive. This part was fun because it was where I realized how the calculate movement portion of my code actually worked. Up until now, I had just copied it from, I think, a Brachy's tutorial and called it a day. I might not have fully understood it at this time, but I at least kind of got it because my calculate only Y movement function has no chaff to it. Funny enough though, I did make an unrelated mistake, but in order to explain this mistake to you, I have to explain something else first. Time.delta time is a variable that holds the time between the previous frame and the current frame. Multiplying by this value effectively allows for you to multiply by time independent of the frame rate. The mistake I made was multiplying by time.delta time 3 times. I'm not certain how this one got by me. Anyone who's taken high school level physics knows the position of y equals 1/2 times acceleration times time squared. And I took AP Physics twice like a lunatic. Dropped out halfway through AP Physics 2 though. Here's how the normal calculate movement function works. We calculate an angle by determining the direction the camera is facing and then adding the player input onto that. This is the angle that we want the player to move in. If the player is pressing left, they ought to move left relative to the camera. Next, we plug that target angle into a smoothing function so that the player doesn't snap straight into that direction. Then we just apply our smoothed rotation to the character. We use the same target angle multiplied by a vector to determine a direction. You can think of a vector as just being a direction plus a magnitude. We take that vector, multiply it by our speed and time.delta time, and we have our horizontal direction. Our y is calculated by a different function, but we can add it onto our vector here. Finally, all we do is tell Unity to move the player in this final direction. The solution to our original problem was nothing more than removing the rotation calculation and the horizontal movement when there's no player input. Next, I made an only slightly less shitty loop animation for falling. I can't believe I'm still using this today. I really need to go back and refine it some more. There was a problem that was frustrating me that I finally managed to reliably reproduce, caused by switching state mid-tick. The issue with switching in the middle is that the code for entering the next state will run, and then the computer returns back and executes the rest of the tick function. In this case, the state switches to run, then on enter in the run function, the speed is switched to run speed. Then returning to walk trot state, the rest of the tick function executes, which includes the speed transition function, overriding the change of player speed to run speed. The super easy solution is to just throw all the state switch checks at the end of the tick function. Next on my list of movements to create was a vertical dash. Hi puppy. I started this by trying to use vector3.lerp. Lerp works by taking 3 values, a start position, an end position, and a time value. Technically, the documentation doesn't say time, and time doesn't strictly make sense. We all know T does in fact stand for time, because it's the only logical thing for it to be abbreviated to, even if it doesn't make actual sense. I mean, what else is it gonna stand for? Taint? You can't lie to me anymore, Unity!
You sit on a throne of lies.
When the time value is at 0, the player's at the start position, and when it's at 1, the player's at the end position. This code has 2 problems to it. Scratch that. It has a lot of problems, but 2 stick out more than the rest. If I wanted to use this specific code, I would be given a vector position in absolute space, rather than an incremental movement. Using an absolute position would effectively disable the collider on the character controller. Moreover, I don't have a decent way, that I know of, to have fine-tuned control over the time value. Fortunately, there's another way to do it. I'm sure there's like 50 other ways to do it, but I'm not that knowledgeable yet. We can use a custom curve to define the velocity at any given point in the movement. This curve operates on the same 0 to 1 principle, and using some basic math in conjunction with a timer, we can define both the amount of the dash and the time of the dash in the editor. Can you spot the problem? That's right, I wasn't able to move after I vertical dashed. As it was possible for the player to enter landing state without giving any input, switch to idle state and run enter, finish executing the original code, and enter walk trot state all at once. A few return statements fixes this issue right up. Now for those of you who followed along with the drinking game so far, how many did you spot? I counted 23. If you managed to find them all, congratulations. Also, please seek medical attention. You'd think that I would have learned from the vertical dash to not lerp, and yet here I am, doing the same thing with a horizontal dash. I don't think I fully understood lerp at this point because the lerp function is completely irrelevant in this situation. Since I'm starting from a position 0, I only needed to multiply the end position by the curve. I added in a time-independent multiplier so I can define a distance and a time independent of each other in the editor. This makes it much easier to play with numbers to create something that feels good, because each one no longer affects the other. In addition to this, I made it so that the player can move slightly, but only slightly vertical when horizontal dashing for a little extra flexibility. It's time to work on double jump, and with that, it's time to finally fix my jump formula. I define a gravity and an initial jump velocity based on a jump height and a jump time, as well as a stronger initial velocity and gravity for a double jump. The double jump script is more or less the same, but the falling script is changed to switch gravity amounts depending on whether or not the player has already double jumped. All in all, minus a few tweaks, it was pretty easy to implement double jumping. So I've been showing you guys a function pretty frequently. It's called crossfade, and it's used to switch between animations. My original assumption of the situation was that if I put a 0.4 in the animation transition slot, then animations would fade over 0.4 seconds. Wrong. This number actually represents the percentage of the animation that is crossed over. In other words, a 10-second animation would take 4 seconds to fade between. It's an easy enough fix though. I know the difference between these two clips doesn't look like much, but it feels remarkably less painful as the one playing. Like I'm free to fly away and chase my dreams, rather than being trapped on the edge of something I can't escape. The final thing I wanted to have working for this video was a portal mechanic. My original idea was that Hati would be able to summon a portal, run through a tunnel in a mysterious realm, and then pop out the other side, having effectively phased through that area. From a gameplay perspective, this may cause issues with explaining why Hati can't just phase through the boundaries of the level, although I have a solution for this. A much more immediately pressing concern is I can't get this mechanic to work at all. I spent quite a lot of time trying to figure this one out, but unfortunately to little avail. I'm confident that I could get the act of teleporting correct given more time, but the view through the portals is very glitchy and shader language is completely incomprehensible to me. So for the foreseeable future, this one's going on the shelf. And that is my progress. Movement is undoubtedly the most important thing in any platformer, so I'm gonna make sure I take my time and really nail this. I also have the wall run mechanics almost entirely completed, but this script was getting long and there's a lot to explain with how wall running works, so I decided it would make a nice part 2. It felt appropriate that this be part 1 of my devlog series, because this is the first time that I feel like I have anything even remotely approaching a game. There will probably be a part 3 of working on movement that focuses on animations and polish for the systems I have now, but I haven't completed work on it yet, so we'll see what I decide. I'm super looking forward to where this project takes me. I feel like it has a ton of potential just waiting to be uncovered, and I hope to take with me any viewers who desire to come along for the ride. Everything else having been said. Until next time, live well.